What if I told you? One single inverter can run an entire house, but in most off-grid systems, it either struggles or slowly breaks down. At first, the idea sounds simple. You install one powerful inverter, connect it to your battery bank, and everything in your house just works. But in real-world off-grid setups, running a whole house on a single inverter is where hidden limitations start to show. At the beginning, everything works fine. But over time, small stresses begin to build, determining whether the setup actually succeeds or fails. Now let's break down the first major factor: total load demand. Every house has two types of loads: continuous loads and surge loads. Continuous loads are things like lights and fridges that run steadily. Surge loads come from pumps or power tools needing a burst of power. A single inverter might handle normal usage easily, but if multiple high-surge devices start at once, it can overload instantly. And when that happens, the inverter either shuts down or gets pushed into stress conditions that reduce its lifespan. The second major issue is load diversity. A house doesn't use power in a smooth, predictable way. Loads turn on and off constantly. Some devices are sensitive, others are heavy-duty. A single inverter has to handle all of that variation at once. Now let's talk about system bottlenecks. When you rely on one inverter, it becomes the central point of failure. If it fails, the entire house loses power instantly. There's no redundancy, no backup path, no flexibility. Inverters are most efficient within certain load ranges, but a house rarely stays in that range, causing the inverter to waste energy. A single inverter locks your system into a fixed capacity. If your energy needs grow, you can't easily expand. When one inverter handles the entire house, all heat is concentrated in a single unit, increasing the risk of thermal shutdowns. These sudden high current draws also create stress on your battery bank, increasing heat and long-term degradation. Yes, one inverter can run a house, but whether it should depends on how the system is designed. That's why many advanced off-grid systems use multiple inverters or parallel setups to spread the load and add redundancy. A well-designed system matches capacity to real usage and avoids constant extremes. Resilience matters just as much as power. In off-grid living, anything that carries all the load eventually carries all the failure too. Make sure your system can keep running. If you want more deep, real-world breakdowns like this, subscribe to Off-Grid Life Tech.